In this video, you'll learn how to create a binary tree in Python and traverse it in 4 different ways. According to Wikipedia, a binary tree is a tree data structure in which each node has at most 2 children, which are referred to as the left child and the right child. In this lesson, we'll use an object-oriented design. There's a node class, a binary tree class, and a queue class. The node class will have a very simple design. It'll have the root node, the left node, and the right node. Most of the work will be carried out by the binary tree class. It will assemble the tree and implement the traversal methods: preorder, inorder, postorder, and levelorder. The queue class will organize nodes in the queue for the levelorder method of the binary tree class. It'll have the ability to add a node to the queue, delete a node from the queue, and get the value of each node. I'm going to start by creating a node class. Class node. We're going to define the init method here. Self, and this will accept a value and then potentially a left and right node. So from the start, I'm going to set this up as none just to keep it simple. Right node equals none, and then I'm going to set up each of these variables here. Value equals value, self.left to keep it short equals left node, and self.right equals right node. That's pretty much it for this particular class. So it receives a value, it receives potentially a left node and right node, and since I can actually instantiate this particular object just with a value, I'm setting up the left node and the right node variables here to none. So the next class that I'll set up here will be the binary tree class. That's the class that's going to organize the information as a tree. Class binary tree, and the init method, self, and all this one here is going to accept at the moment of instantiation will be a node. This node is going to be an actual node passed in into this binary tree class. So self, I'm going to call this variable root because this will be the root node every time we make reference to the node that's being accepted. And I'm going to assign node to it. That's it. Next step here will be to set up the different ways of traversing this particular tree. So the first method will be the preorder method, and this method will receive a start node as a parameter, start node, and then traversal will be a string that's going to keep a sequence of the values in a tree. So I'm going to check to see if there's a start node. If there is, then I'm going to say that traversal plus equals, here I'm going to collect the value of this particular node. So I'm going to actually set this up as a f string. I'm going to as strings just to make it simple. So I'm going to use the str function here, and then I'm going to pass in start node dot value. I'm going to create a space here between these values so it looks organized, and that's pretty much it. And then in the preorder setup, then we have the root, then we have the left node and right node. So now I'm going to assign the left node to the traversal assign the left node to the traversal string for this variable here. So I'm going to do it, and this I'll be using recurrence as a structure here to get to all these nodes. So self preorder, I'm going to call the same function. I'm going to pass start node dot left now. I'm going to pass the traversal. That's going to contain whatever is, was passed as a value originally. And then the next one will be traversal equals self dot preorder start node dot right, and then a traversal string as well. And now all I have to, oops, let me just call this here again. I'm going to copy. It's not going to work so well. Let's see, let's try it again. Traversal equals self dot preorder start node dot right node this time, traversal, and now I'm going to return this variable traversal. Return traversal. So this is the first method for traversing through this tree. This is a preorder. Again, it starts with the root node and then goes to the left node and the right node. The next in line will be def Inorder. Same structure, same signature here for this method. And only now I'm going to start with the left node. So left node, root, and right node. So this would be if start node, then traversal equals self. I'm going to call the function again, Inorder start node, and then traversal string. Traversal. Now I'm going to collect the value of the root node, and this will be another f string, and I'm going to make this a string. I'm going to say start node dot value, and again, just for formatting purposes, I'm going to create a space here with this hyphen, and then finally I'm going to assign to this variable traversal the results of another call to the Inorder function or method. Start node dot right this time, traversal, and now I'm going to return traversal the same way we did before. All right, so now I'm going to set up a method to do a post-order traversal. Post-order self start node. All these methods have pretty much the same signature, traversal. And in a post-order, it's going to be left node, right node, and then the root. So if start node, then I'm going to say traversal equals self dot, I'm going to call the same method. It's a recurrence call here, and start node left, and then again self dot post order start node dot right, and finally we're going to collect the value of the node self f string, and here I'm going to say start node dot value, and again I'm going to create a space hyphen space here just to keep the values all separated. Now I have to return traversal. Okay, also I want to give this program the ability to traverse by level of this hierarchy. If you're enjoying this video, please hit the like button and stick around because I have a bonus for you. Later at the end, I'm going to show you how to search a binary tree for a specific value. So this is one level, another level, another level. So there are 3 levels here, counting the root node level. So I want to set up a method that will do that. So this would be def, I'm going to call it level order, self start node traversal. As before, colon, if start node. In here, because this method will use a different approach to how to reach each of the nodes, we're going to have to set up some sort of queue to get them in order, because the final output will have to be 1, 2, 3, 4, 5, 6, 7 in order. So for now, I'm just going to pass, and then that will give me an opportunity to create a class. I'm going to call it a queue class, and this will keep the elements in order for output. I'm going to create this up here. I'm just going to move this up. So class. Oops, can't spell. Okay. And then the init method to initialize this particular class. Self. It'll take no parameters. All I'm going to set up here as far as attributes would be an empty list. So this will be self.items equals an empty list. So this class will have to give me the ability to put an item in a queue. And so I'm going to set up a method. I'm going to call it Enqueue. And as a parameter, it'll take an item. It's making reference to an item that's going to be part of this list. And then I'm just going to say self.items. I'm going to use insert, the method insert, because I want the item to go in a specific index. So this will be index 0, because I want it to be set up on the left. If you think of a list, then this is my left, so this will be the first item here. And then as another item is put here, this one keeps moving to the right, and to the right. So this will be position 0, and I'm going to pass in the item. That's pretty much it. Also need a way to dequeue an item, so I'm going to set it up as dequeue self. So I'm going to use self.items. I'm going to pop this self.items.pop. When I use pop here without passing any parameters, it's going to pick the rightmost element or item in that particular queue or list. So, but I like things to be very explicit. I'm just going to say it's -1. So it's going to be in the -1 position. This will be the last item on the right of that list. And because pop also returns a value, so I'm going to say, I'm going to return that value when somebody calls this method dequeue, because that's going to be useful in that level order method down there. Also, we need a way to get the item to process. So I'm going to say get item self, and it's going to be, I'm going to return it, return self.items. I'm going to pick the item that's all the way to the right. So that was the first one in the list, and then it kept being moved to the right until so that's always, you know, the last one on the list, and the one that's got to come out first. So I'm going to say position -1, but I don't want the node, I want the value, so I'm going to say like this. Okay, finally, just to make things simple in my code, I'm just going to modify the built-in len function or len method. I'm going to say len self. So anytime I call the built-in len function, I want this here to be returned. So return the length of the self.items list. So this will become obvious later on in the code, because I'm going to refer to length of a queue, not length of self.items. That's pretty much it for now. So I'm going to just run this whole thing here, see if there's any errors. Oh, there's an error. Let's see what's going on here. Syntax, invalid syntax. On the first line, oh, I see, there's no space. Like that. Let me run this again. All right, so no errors this time. So now I'm going to continue with this level order method here. So the first order of business will be to create an instance of the Dequeue class. So I'm going to say queue equals to queue, like that. And then I'm going to enqueue this node that's being passed to this method. So queue.enqueue start node. Okay. And now I'm going to say, I'm going to create a loop here, while length of queue. So that's why I modified the built-in length function here, like that. I can say while the length of queue is greater than 0. So while there's still an item on that queue list, I'm going to do the following. So the first order of business will be to populate the traversal variable here. So I'm going to say traversal, and now I'm going to use that get item method to access the value of this node here. So this would be, I'm going to set this up as a nef string, and I'm going to, again, whatever the content is, I'm going to turn that into a string, because the values of each node is actually numbers. And let's see, I'm going to say queue dot get item, like that. And also, like I've done before, I'm going to create a space here, because this traversal variable here is going to have a list of numbers, and I want to separate those numbers with space and a hyphen. And then, all right, so once I got the item, I have to dequeue that item so I don't access it again. So I'm going to say queue.dequeue. It's going to pop that item out of the list. And again, since there's a return value on the dequeue here, there's a return value. So whatever is deleted is going to be returned, and that's going to be useful right now. So I'm going to capture that value. Node, I'm going to call it deleted node equals that. And then I'm going to say, well, if deleted node dot left, if this node that was deleted has a left node, I'm going to enqueue that node. So I'm going to say queue dot enqueue, and it's going to be deleted node dot left, like that. Also, you want to check to see if there's a right node as well. So if deleted node had a right node, I'm going to enqueue that node. Now all I have to do is return traversal. Return traversal, just like the other ones. So all these methods, they have the same signature. They return the same kind of variable, and they accept the same number and types of parameters. Good. So now we need a way to print the values of the tree. As we traverse through the tree, we're going to collect those values and print them, right? And that's what we're trying to do with these methods here. So I'm going to say print tree. I'm going to call this method print tree. And as a parameter, it'll take a string with the name of the traversal type the user wants to use in order to go through this binary tree. So I'm going to call this traversal or trav type. Now I'm going to take a look at this traversal type. If traversal type dot lower, because I want to make sure I don't get errors left and right simply because the person capitalized a letter or another when they wrote the name of the traversal type, equals preorder. So when this happens, I'm going to return self preorder. That's one of the methods here, and I'm going to pass as the, what does it call for? It calls for the start node. So the start node is going to be the self.root, and then I'm going to pass in a traversal, which is going to be like an empty string for now. All right. If the user picks this type, preorder type of traversal, then this method is going to be applied. When this method returns something, it's going to return, let's see here, preorder. It's going to return all the values separated by these hyphen space, and it's going to look good inside the list, but then at the end of the list we're going to have space, hyphen, and space. We want to get rid of that, so we're going to do a slicing here on the return. So I'm going to say -3, so it's not going to include 1, 2, 3 here, space, hyphen, space. All right, so elif traversal type dot lower equals. Now we're going to pick in order. All I'm going to do is return self dot in order, so that method, pass in self dot root, and pass in an empty string. I'm going to do the slice in the same way because all these methods, they have the same setup here at the end. So -3, and then elif traversal type dot lower equals post order now, and then I'm going to I messed up here. All right, so I'm going to return self.postOrder, pass in the root, and then empty string as traversal. Do the slicing in the same manner. All right, and then elif traversal type dot lower equals level order. Then I'm going to return self.postOrder method and pass in the root and empty string. All of these methods still take the root as the starting node. Now do the slicing, and then finally, if whatever the user writes here, it's not any of these, I'm going to do a catch-all return here. So it's going to be else. I'm going to say return return an F string. I'm going to say trav type is not a recognized traversal type. All right, so it looks good. Hopefully there's no errors. Let me just run this to make sure. All right, no errors. Now we can start to instantiate these classes. All right, so I'm going to do it like this here. I'm going to say instantiate the tree first. Tree equals binary tree, and then it calls for an argument to be passed in. So I'm going to pass in node 1 node. So I'm instantiating this class node inside the call to the binary function here, binary tree. And then as a next level, now we need to get node 2 and 3 in as well. So it's going to be tree dot root dot left equals node 2, and then tree dot root dot right. Well, the reason why, the reason why I set the binary tree, not the binary tree, sorry, I set the class node with the left node and right node as with default values of none, is because if when instantiating the class, if there's no left node immediately or right node, then you wouldn't get an error. So, and that's what happened here. I'm just passing in the value, but not the left or the right node. I'm just saying node 2. Now I'm going to say node 3. Okay, one more level to get the 4, 5, 6, 7. Tree dot root dot left dot left equals node, and this will be 4. And then tree dot root dot left, so it goes under this one here. Now a right node, which is the 5, equals to node 5. And then finally we're going to address these over here. Tree root dot right dot left equals node 6. Tree dot root dot right dot right, now we're talking about the 7, equals node, oops, not Biden, node 7. Let me just run this here, make sure there's no error. Okay, beautiful. So now let's test it. We're going to say print tree dot print tree, and I'm going to pass in as a parameter a string with the name that of the traversal type that I want. I'm going to say preorder first and go through this in order. Let's see if there's an error. There isn't an error, so it's printing root left, oops, oh, roots, and then it goes all the way down here, left, left, all the lefts, so 1, 2, 4, 5, and then goes up to the right, so get this one right, and then all the way to the other right, so the 3, and then it goes the first left, and then it goes the first right. So 1, 2, 4, 5, 3, 6, 7. Let's now try another one. Let's say print tree dot print tree. I'm going to pass in now in order. This time just to test to see if the code will accept something with capital letters. So the I is capitalized here. Make sure it works. So there's an error. Let's see what the error is. Self in order, start node. Okay, so this should be a left here, and it's not. So line 14, this should be the left node. Let me run this again. And now it worked. So the order is completely different now because we're going left node, root node, and right node. Let's keep on testing the other ones. Print tree dot print tree. I'm going to say all in capital post order. Make sure it works this way. Another error. This one here. What is the problem? Self post order start node dot left, or I didn't pass in the traversal variable. So 21. So I'm going to say traversal. And then this one here, traversal. I'm going to run the whole thing. Well, there's a logic problem here. So let's see, post order. Oh, I see. So when I pass the value here to this traversal variable, I did not use the plus sign here. Run again. Now you have it. So it starts with a 4, but it's a different order than this one here. And then finally we have the level order. Print tree dot print tree. I'm going to say level order. So this should produce simply the numbers 1 to 7 in order. And it doesn't. Okay, so there's a problem here. Let's see what that is. Oh, I know what it is. I'm probably calling this one here inside the level order. Let's see. Oh, wait a minute. It's not here. It's in the print tree. So level order. So if it is level order, see, I'm making a mistake here. So it should be level order. Okay, let me just run this again. No, it works. 1, 2, 3, 4, 5, 6, 7. Excellent. Here's the bonus I promised early in this video. I'll add the ability to search the tree for a specific value to the BinaryTree class. Finally, just to end this, I said that this program would traverse through a hierarchical data structure, but I also said that it would search through it for a specific value. So I'm going to create a function here, a method, that will do just that. I'm going to say def search tree self. I'm going to say, well, we need a value, so I'm going to pass in a value, and then we need a traversal function to be used. So the user is going to choose which one. Trav func. I'm going to call it this way. And then I'm going to say, well, I'm going to call this traversal function whatever is chosen by the user, and then that's going to produce a result, right? So I want to get those results not as a list separated by hyphens and spaces, but as a list separated by commas, because I'm going to iterate through that list. So this is what I'm going to do in the first line here. I'm going to say values list, just to emphasize that now it's a list. The value should be separated by comma. I'm going to say traversal function. I'm going to pass in root, because when we search this binary tree, we're going to search from the root all the way through all the levels of the tree. And then I'm going to pass in the empty string, just like we did before. And again, we're going to have to slice it because we don't want those space, hyphen, space at the end. So I'm going to say like this. And then I want to remove these separators, the space, hyphen, space. I want to remove these here and replace them with a comma. And the easiest way to do this is to call the split method on this string, because this whole thing here is going to produce a string. I'm going to call that split method on that, and I'm going to I want it to split on space, hyphen, space, just like that. Beautiful. Okay, now I'm going to initialize a variable called result. So this will be the result of the search. It's going to contain an empty string for now. And then we're going to do a loop. I'm going to say for. I want the search result to show the index of the result on the particular position and the tree, and then whether the result is true or false for this particular value that's going to be passed in here. So I'm going to say for index, and then I'm going to say num in that list, and enumerate. I'm going to use enumerate because that's going to give me the index. And I'm going to pass in the values list as an argument here. I'm going to say if this number equals value. But since value here is going to be a number, most likely I'm going to use this function string. So if a number on this tree here it's equal to the string version of the value passed in, then we're going to add true to the string. So we're going to say result equals plus equals is going to say, I'm going to use another, I like F strings, so I'm going to say index, and then usually indexes they go from 0 and then forward, but I want this to start at 1, so I'm going to say index plus 1, and then I'm going to say true space hyphen space. So I'm building the all the results that we put in this variable here. Okay, now else I'm going to say result plus equals same type of F string. I'm going to say index plus 1, whatever the index is, and then I'm going to say false space hyphen space. And now all I have to do is return this, return result, and then the result will have at the end the same situation here, space hyphen space. I want to remove that by slicing like this. Okay, let's see if this works. First I'm going to run this, make sure it works fine, no errors. I'm going to call it down here. I'm going to say print tree dot search tree. I'm going to pass in, pick a value. I'm going to pick 4, and then I'm going to pass in a function. I'm going to say tree dot preorder, like that. So this is not a variable, this is a reference to the actual function. I'm going to run it, and then it gives me the result. So, and here it is on position 3, there's a 4. So let's look at preorder. And 1, 2, 3, here's the 4. So it's correct. So let's do the same thing for the others. Print tree dot search tree. I'm going to pass in 4 just to compare. Tree dot, now I'm going to do in order and see what happens. So in order, where is 4? In order, 4 is the first one on the left, and it is true here. Everything else is false. Let's try one more. Print tree dot search tree. I'm going to pass in 4 again. This time post tree dot post order, and see if it works. Yeah, 4 is in the first position again. As we can see here, post order 4. Everything else is false. And then let's do level order, see what happens now. Print tree dot search tree. I'm going to pass in 4, and I'm going to say tree dot level order. I'm going to run this, and then it should be in the 4th position, right? 1, 2, 3, 4. It's true. It works. Everything works perfectly. So that's it. That's one way to set up a hierarchical data structure, in this particular case a binary tree, and set it up and have a way using object-oriented approach and having a way to traverse through this tree and to search for specific values or nodes. And this program does that. That's it. It's already a very long video, but that's the best I could do in this time. I hope this video helped to show you how to create, traverse, and search a binary tree in Python. If you like this video, make sure to subscribe so you don't miss out on more videos like this one. Just click on the subscribe button below and remember to hit that like button. Now, I want to hear from you. Are you interested in Python solely as a hobby or as a career? Please let me know in the comments below today. And if you don't want to miss my next video, make sure to hit the notification bell.